So Canada emits about 730 million tons of carbon dioxide emissions every year. Our agriculture sector itself contributes to about 60 million tons of CO2 equivalent every year. Methane emission just from the swine production, manure management, etc. It's about 1,700 kilotons of CO2 equivalent methane emissions every year. So we are working towards a net zero emission for 2050. So for that, we have to know what we are dealing with.
We have a lot of people on the planet that we need to feed. And so we need to figure out how to do that in the most responsible way that we can. And that's really where the cross-section between food production and agriculture and emissions comes. And we want to make sure that as a responsible corporate citizen that we are doing our part to help.
The Cluster 4 project aims to develop strategies to mitigate greenhouse gas emissions. From the manure production chain, storage, how we collect them, store, and then until it land applied, what are the greenhouse gas emissions throughout the pathway? And we are trying to find a solution to measure the baseline emissions and provide biological solutions, and also to mitigate greenhouse gas emissions throughout the chain. And we would like to research on how to capture them. If you let it go onto the atmosphere, it's a greenhouse gas emissions. But if you capture them, can we add value to those so-called waste? We are focusing on something like waste is not waste, but misplaced resources. And that's why the baseline emissions are very important. To understand the baseline emissions from the production unit itself. My collaborator, Razak from Ottawa Research Center, is responsible on knowing the emissions from the production side. All the values that we use, it's from literatures, from theoretical values. The animal operations, the feeding strategies, and the way we grow the animal in cold climate, it's not the same as compared to the other countries, right? So those values that we take from the literature may not be the representative. We have chosen few representative forms, and we wanted to know what are the baseline emissions, real-time emissions from the site itself. So when you know how much we are emitting, we'd be able to suggest or propose alternatives to mitigate them. We would like to develop the technology or share our expertise on low temperature anaerobic digestion as well, because around the world, most of the existing digesters are 35 to 50 degrees Celsius. And what we are working at Agriculture and Agri-Food Canada, especially on Sherbrooke Research Center, 20 to 25 degrees Celsius, because it has a lot of benefits in terms of saving energy, producing energy. At the same time, the fluctuations in the temperature, we'd be able to maintain the active microorganism in order to do this job. And that's a specialty, and that's where Maple Leaf Foods, they approached us to involve in this project and share our expertise in finding solutions together.
Maple Leaf Foods is the first major food company to become carbon neutral. So far, we've done that through the purchase of carbon offsets. But we do have really lofty goals to reduce our absolute Scope 1 and Scope 2 emissions by 30% by 2030. We've made a lot of assumptions on what our carbon emissions are. And as we dug into the details on that, we noticed that a lot of the research was done in climates that were not reflective of where we are operating. And we wanted to make sure that the emissions that we were assuming were the ones that we are actually producing. We know that there is a link between methane production and temperature, so we do think that our emissions have been perhaps overstated a little bit, and that has real economic impact to us.
Whenever you talk to our producers, the first thing comes in their mind is the odor nuisance in managing their manure. And anaerobic digestion is one such biotechnology. You reduce vastly the odor. And second thing, there are a lot of antibiotics involved, some harmful bacteria involved, like for example, swine fever, all kind of issues we have been hearing day-to-day life. So they have to manage manure not just manage, but also in a biosafety, biosecurity way to do that. And that's where our technology comes in. First of all, it produces bioenergy, so your dependency on fossil fuels, get reduced. And second thing is that harmful bacteria, we'll be able to vastly reduce them, so it is safe to apply on land and grow crops, etc. At the same time, the methanes, from the storage tanks, it's huge. By having anaerobic digestion, we would be able to reduce 60 to 70% of the greenhouse gas emissions annually. Even if you reduce 50%, you would be able to eliminate 1.5 million cars on the road annually. We have been developing two different kinds of anaerobic digesters. One is a liquid part and other one is a solid digestion part. A liquid part is a mature technology, and we do have a showcase technology at our center. We would be able to treat with this technology. And around the world, mesophilic and thermophilic temperatures, that means like 35 to 50 degrees Celsius, lower temperature, you'll be able to handle high ammonia waste. Then multiple substrate, like you have swine, dairy, and goat, all in one campus, right? So with the crop residues, all these things together as a multi-substrate can be handled with our biodigester, with a low technology biodigester. This is one. So this is expensive. I know the liquid part is expensive because it involves your mixing unit, pumping unit, all those things. But there are lots of farms, they are having a solid manure. The total solids are in the range of 30-35%. So we have to dilute to be treated in the liquid digesters. We are developing a solid digester, so we don't have to dilute anything. Just take the manure as is, but your size of the digester reduce 10 times. But of course, it's in a research stage for now. And this is what I would like to see as a future for the farmers. They could have a liquid solid separator on site. So the liquid, they can do whatever they want, and the solid can go in the anaerobic digester. In this way, after treatment, not just the biogas, your digestate, the treated material after anaerobic digester, are rich in nutrients like a phosphor, fertilizer, and they can store them in a dry form, moisture-free dry form, and they can apply whenever they want. So it's not another greenhouse gas emissions when you transport the liquid digestate from one point to other point. That's another CO2 emission. But what happens if you store on site, and you can take them and use them whenever you want, or you can export them in a concentrated form. That makes sense for the farmers, and also it encourages the concept of circular economy. So that's also very important. What comes from the farm will go back to the farm, but also increase their economy viability as well. We have a scientific collaboration among the researchers. We have the industrial collaborators to work with us. And we have been collaborating with some universities, Guelph University, McGill University. Of course, these collaborations really help.
Collaboration between the industry and the producers and the government all working together is going to be where we come up with ideas that are practical and make economic sense and are easy to implement and have real impacts to our carbon emissions.
We need to have a research projects and funding to experiment it, research it, to find this is a practical solution for the farmer. One solution doesn't fit to any farms. We need to have different solutions, different approach for different needs.